In this video, we're going to talk about absolute value functions. So our basic function is f of x equals the absolute value of x. And the basic idea of absolute value is that it is the distance of a value from 0 on the number line. So for example, if we think of 5 and negative 5, the absolute value of either of those is equal to 5 because they have the same distance away from 0 on that number line. Let's look at a couple simple equations to solve to show you how they work. So if we're given the absolute value of x plus 5 equals 17, what we do is set up two equations, again thinking of this same idea we saw right here. X plus 5, so we're not sure if what was in there was 17 or negative 17, because the absolute value of either would give us 17. So we have to set up both. We're going to say x plus 5 could have been 17, but it could have also been negative 17 for this basic reason in red right here. And then we just solve each one of these equations separately. So then if we subtract 5, x would equal 12 as one possibility. And if we subtract 5 on the right, x would equal negative 22 is our other possibility. So we have two solutions to this equation. For example 2, we have the absolute value of 3n minus 4 equals negative 1. In this case, absolute value, just like we talked about, is distance from 0. So it cannot equal a negative. This one does not make sense. So we're just going to write not possible. Absolute value of anything cannot equal a negative, because that's all that's written right there. There's nothing extra. Then let's look at one more of these regular examples that do work. So if we have the absolute value of 2t minus 4 equals 8, we need to set up two possibilities. 2t minus 4 could have been equal to 8, or 2t minus 4 could have equaled negative 8. And then we just have to solve. So if we add 4 to both sides, we end up with 2t equals 12. And then if we divide by 2, t would equal 6 as one of our solutions. And then on the right, if we added 4 to both sides, we get 2t equals negative 4. And if we divide by 2, t would equal negative 2 as our other solution. All right, so let's take the same idea. Notice that we've set them equal to a positive and a negative, and a positive and a negative of what it's equal to. And we're going to look at some graphs. So we're going to take the same concept and look at this basic absolute value parent function of ours. Y equals absolute value of x. So we are actually going to graph y equals x and y equals negative x, because that's where the absolute value of x comes from. And we just cannot include values of y that would be negative. So y is not equal to negative anything. So if we're graphing y equals x, that is that basic line through the middle of our graph, right? Where it goes straight through here. And if we graph y equals negative x, that graph would go in the opposite direction, but straight through the middle. But then we're saying y can't be a negative. So our graph cannot exist underneath this 0 right here. So absolute value turns out to always look like a V-shaped graph, just because these values won't make any sense. So we do not include those. Now let's take a look at this with piecewise graph. So like this turns out to be a piecewise function in its basic form. So if we say f of x equals, and set this up like a piecewise function, we would say y equals x for values of x that are, so notice this is that positive line, this is that first one we looked at. It's for all the values that are greater than 0. So we're going to say if x is greater than 0. And then y equals 0, if x equals 0, is that point right in the middle. And then this line represents the other piece of our piecewise function, and that's saying y equals negative x. So y would equal negative x, but only if x is less than 0. We have to say that it doesn't include these pieces down here at the bottom. And so we can write it this way because this would represent only those parts of our graph that make sense with absolute value. Let's do one that's not just the parent function, but has a little bit more to it. So if we have the absolute value of x minus 4, we're really looking at graphs of the positive, like what it looks like, or the negative, so change your signs. So treat it like it's the complete opposite. So if we look at the graph of y equals x minus 4, we have a y-intercept of negative 4, and then it has a slope of 1. So it will look something like this. And then if we have the graph of negative x plus 4, we have a y-intercept at positive 4, and then it has a negative 1 for a slope. So it looks something like this. And then we're still saying the same thing we did up here. Y cannot equal a negative. So these bottom pieces of our graph are no longer going to apply. They don't make any sense. So we draw this top part of our graph solid. These really are no longer in existence because we're dealing with absolute value and y cannot be negative. Now let's write it as a piecewise function. So let's write it properly. We're going to say for this piece right here, that was our positive graph, y equals x minus 4, but it's only if x is greater than 4, is what we could say. Then say y equals 0 if x equals 0, so similar to that first example. And then y would equal negative x plus 4, so that's kind of like our negative graph that we set up, if x is less than 4, because that's that piece going off to the left right there. So when you graph these, you really don't include this bottom part at all. That's why with our parent functions we've already looked at that you only see that V-shaped graph. It's because these values I left in dashed lines are not there. They don't exist. But that's kind of where this V is coming from. It's two lines, but then the part that's undefined gets left out of our function. And then I just wanted to show you that you can also write these as piecewise functions, because that is what they are in their basic form. All right, so that's it for now.